Kia ora Year 11 and 12. Here are the next couple of bits from the November 2017 AS paper. These two questions are both on sequences. So for this, if you're doing A-level, you may have forgotten some of this and you might need to grab the formula sheet, but I'll put the relevant ones in as we go. If you're doing AS though, this should be pretty familiar to you from the internal that you did. So this is a really good place to get full marks in the paper. With first question, we've got a geometric progression and we're given the first term and the common ratio is R. And then we've got another geometric progression with the first term A and common ratio negative 2R, and they've got the same sum to infinity. So the sum to infinity formula is one that you should all remember without looking, because it's so straightforward. S to infinity is equal to A over 1 minus R. And we have to figure out the value of R. So pause the video and work through that question if you haven't already done it. Right, so what we get is we've got the first sequence has got first term of A and common ratio of R. So its sum to infinity is going to be 3a over 1 minus r. And that's the same as the second one, which has got a first term of a and a common ratio of negative 2r. So we get a over 1 minus negative 2r. So solving those goes as follows. We've got 3a times 1 plus 2r is equal to a times 1 minus r. Expanding out and then collecting up terms gives me 3a plus 6r is equal to a minus ar. Remember, my goal is to figure out r, so let's clean that up a little bit and see what we get. Well, we've got, that's not right, I've lost an a. There's 6ar there. Okay, so 7ar is equal to negative 2a. All I've done is just collect up like terms as if I were back in year 9. And I know that a is not equal to 0. Do I know that? Let's have a look. I'm not really told. Oh, it's a geometric. So if a was 0, then the whole thing would just stay at 0, which would be boring. So we can assume that a is not equal to 0, and that means that we can divide through by it. And we get 7r is equal to negative 2, giving us r is equal to negative 2 over 7. So that's the first 3 marks done. Right, let's have a look at the next bit. Okay, this one is about an arithmetic progression, and again there are 2 of them, and we're comparing them. And this time these have got the same sum of the first n terms, and we have to figure out what that value of n is. So the first 2 terms of one arithmetic progression are 15 and 19, so that means that a is 15 and d is 4. For the next one, we start with 420 and we go down to 415. So a is 420 and d is negative 5. Now there are 2 formulae for the sum of an arithmetic progression. One of them is where you know the first and the last term, but we don't know that here. And the other one is the one that we're going to use, which is this one. So the sum of n terms is equal to this. Right, now I'm not going to derive this in here, but it's pretty cool. You would have done that in class. So we know that these are equal for some value of n. So all we really have to do now is to substitute in. And for the first one, we get a half n times 2a, so that's 30, plus n minus 1 times the difference, which is 4. And that is the same for some value of n of this one. So 2a will be 840. Plus n minus 1 times negative 5. Now that's very badly written out. I'm going to change my pen. I can feel some of you going, why is she doing this erasing thing as she goes? Because I didn't organise this very well. Now I've got n is not equal to 0, so I can divide through by both sides by half n. That leaves me with this bit and this bit. So I get 30 plus 4n minus 4 is equal to 840 minus 5n plus 5. 26 plus 4n is equal to 845 minus 5n. 9n is equal to 819, which gives me a final answer. This is a very lovely, easy question. N is equal to 91. So there you go. Well worth going over lots of the sequences and series questions because they are really super easy marks, and it's usually just a matter of substituting the right bits into the right formula. Thanks for watching.